Hi, my name is Marcelo, and this is my first video where I'll be trying to solve some coding problems, live coding. I've chosen to do some Project Euler problems. They're pretty simple. This is the very first one, so it's kind of a hello world problem in a sense. It just asks you to find the sum of all the multiples of 3 or 5 below 1000, and it even includes a test case that for 10 it should equal 23. To get started, yeah, I'll be using in Python, and you can use whatever language you want, of course, because the answer for Project Euler problems is always an integer, which you just see, which it easily checks, and so you can always use whatever programming language you want. So to start, we just initialize a variable, and then we're going to print that as the answer. And if we try it out here, we can see that it does nothing because I didn't save. And now we can see that it prints 0. Again, to try it out, so we just loop from 0 to 10 in this case for a test case, and if x is a multiple of 3 or if x is a multiple of 5, then we just add it up to the total, and now it should work. Yeah, we get 23 just like the test case, and if we change it to 1000, it should work the same way. Works pretty well. It's a very simple problem. We could actually do this in a different way here, since it's such a simple problem, is that you use a list comprehension. So the way we use a list comprehension is just we kind of do the same loop here, and we just repeat it, and we add the condition that if x is a multiple of 3 or if x is a multiple of 5, and we just sum all of these and then print it out. We don't need this anymore, and here we go, same answer. So again, very simple problem, very easy to reason about, and there's many different ways to solve this. You can then just go to Project Euler website and register, and there will be a text box where you can check the answer. But there is a different version of it, which is the HackerRank version. HackerRank adds some different test cases, so it has a simple format where it just includes a number of test cases and a number of inputs, and you have to print in the same way, but a different an output for each input. So if we come here and copy it over our code to kind of work the same way, but we have to pass down a variable for each different test case. And so this should work if our code is correct. And again, if we run the code here, it's going to run against the base test case that is showing, and you get the same answer. So now that you know that's working, we can submit the code and it's passing, but you can see that some cases take a long time to solve and time out. The reason is because this code is inefficient, because it loops from 0 to n. If length too large, this is going to time out. So because this is an O of n algorithm, we can actually do an O of 1 version, and the idea here is to do multiples of 3 plus the multiples of 5 minus the multiples of 15, which are counted twice. There is a simple formula to count the multiples of a number from 0 to n. We can just do the same thing here, and we're just going to pass down the total, the number, and the value which are counting from. And first we have to get the number of terms, which should be, now we'll subtract it from 1 because it should be up to 1, because up to that number, not included that number, and we divide it by n. We use the floor division so that it gets all of the numbers between 0 and v, which are divisible by n, and then we can just return a product of n times p times p plus 1, which are the number of terms. And we can just do floor division again. Now this is always going to be an even number. The idea here is to just print an integer, because if p plus times p plus 1, either one of these is going to be even, so it's always going to be an even number. And here, instead of this list comprehension, we can do a multiples of 3 and the value of n plus the multiples of 5 plus value of n plus multiples of actually it's the difference of multiples of 15 and the value of n. And if you run this code, it should work. Again, you get the same output, and now if you submit it, it's much faster, as you can see, and it runs all test cases. There are still some optimizations we can do this. So HackerRank sometimes they'll have repeat test cases, and it might be wise to just memorize the answers of these values, because if they come up, you can just reference instead of doing this calculation again. But again, now thanks to this formula, our code is O of 1 because it just utilizes the same formula 3 times, regardless of how big n is. And if this is interesting, I will have the link, especially to HackerRank and Project Euler, in the comments. Thanks for watching, and let me know what else you want to see in the channel.